Today is the first lesson of, I guess, kind of advanced trig. So we're going to talk about radians and degrees. But before that, a bit of quick recap. So on the basic trig functions, sine, cosine, and tangent. So sine is, so these three functions are used for angles. And sine theta, say theta is in degree, like 50 degrees or 20 degrees, etc. Sine theta is opposite over hypotenuse, right? Like SOHCAHTOA. TOA. We've learned SOHCAHTOA. TOA. And this stands for sine is opposite over hypotenuse. Okay, so what this means is if I draw this triangle, that is a right triangle, and this is theta. Then sine theta would be equal to this side, so the length of this side over length of this side. Okay, and cosine theta. So cosine theta corresponds to ka. It's just cosine adjacent hypotenuse. Here in this triangle, cosine theta is adjacent over hypotenuse. And then we also have tangent theta, which stands for TOA, which corresponds with TOA. So it's basically saying tangent is opposite over adjacent, meaning tangent theta is opposite over adjacent. So that's a bit of basic review, and there's also some other facts we should know, like the basic values, like the sine, cosine, tangent values are 30 degrees, 45 degrees, 60 degrees, and even maybe even 0 or 90, but these three are the basic angles you need to know for sine, cosine, and tangent. You should have memorized them, or you should be really familiar with these that you don't have to memorize them. But anyways, yeah. So let's move on to radians and degrees. So degrees, as you know, is a way of measuring angles. And angles are basically this part formed by two, you can say lines. So two rays, more specifically. So this is the angle, and we can measure angles using degrees. So degrees basically split this circle. So if this is a circle, it basically splits this circle up into 360 different portions, right? Each portion is called 1 degree. So this circle, so basically you can say that this angle over here, this, I guess, angle is 360 degrees. And radians is also a measurement for angles. So this is something degrees, right? This can also be said as something radians. It's like cm and feet. Two different types of measurements, but they measure the same thing. These just measure an angle. So, for example, so the most important thing to remember here is that this angle over here, that is 360 degrees, is equal to 2 pi radians. Notice the name radians sounds kind of like radius if you think about it. And it's not just a coincidence. This measurement is based on, this measurement is actually just based on the circles. Like here there's a pi, right? What does that correspond to? Basically means if I drew this circle with radius 1, let's say, or any radius, so just ignore the radius, I guess, any circle, a 360 degree would cover the radius, the circumference of the circle. Like a 360 degree angle would cover the circumference of the circle, right? And the circumference is 2 pi r. Now if we say we have the radius is 1, then this 360 degree angle just covers 2 pi length. So we call that 2 pi radians. This angle is 2 pi radians. Other common values are for example, let me draw another circle. 180 degrees, so 180 degrees is pi radians. What does this basically mean? This basically means that 180 degree angle correspondingly covers half of the circumference, right? And one circumference is 2 pi r, or 2 pi if the radius is 1. So half of the circumference is just pi. Yeah. And obviously, we need to remember that 0 degrees is 0 radians. Notice that writing radians each time is kind of long. Like, you know, for degrees we have the symbol, which is really convenient to write. So you can sometimes write radians as rad. For example, 360 degrees is 2 pi rad, or something like that, instead of radians. Okay, so let's do some basic conversion between radians and degrees to get familiarized. So essentially, let me just ask you a simple question. Let's say, what is 30 degrees in radians? 30 degrees equals what? Like, how much radians? Well, a simple conversion is, you know that, well, 30 degrees is, let's say, x radians, right? And we know 180 degrees is pi radians. Like, you should memorize this. You should memorize this really basic fact. And what this means is that if I multiply 100 degrees by, say, 30 over 180, and I multiply the same thing on the other side, pi times 30 over 180 radians, then I get the angle for 30 degrees in radians, because 180 cancels, and we have 30 degrees is, well, this fraction is actually just 1 over 6, so this is just pi over 6 radians. So 30 degrees is pi over 6 radians. Now, a more simple way to do this is just to multiply 30 degrees by, pi over 180 degrees. This is like the conversion factor. This is a conversion factor. So if you multiply this, you again get pi over 6 radians. Okay, so, and this should actually have the unit pi radians, but for conveniency, we sometimes just ignore the unit rad. So 30 degrees times pi radians over 180 degrees is pi over 6 radians, and this is also the answer. So x is just pi over 6. And let's just do another question. Say, what is, let's say, 225 degrees. Let's say this is, again, x radians. Now, using the conversion factors, you can just do 225 times pi radians over 180 degrees. Now, the degree symbols cancel out. You can cancel out units just like you cancel out numbers. Cancel out factors. So 225 and 180, they have obviously a common factor of 5. So if you cancel the 5 out, this is 45, this is 36, and then there's also a factor of 9. So this is 5 and this is 4. So this is just 5 pi over 4 radians. And if you think about it in the, I guess, more logical way that makes sense, if you just learned this, you can think of it as 225 degrees. So I know that 180 degrees is, well, pi radians. So how do I get from 180 to 225? Just multiply both sides by 225 over 180, right? Makes sense. So again, you do the same thing on the right hand side, so you have 225 pi over 180 radians. This is actually just the answer, but you have to simplify the fraction, which is why this is not the final answer. So the 180s cancel out. Notice the unit does not, because there's no unit in our fraction. So we have 225 degrees is equal to, again, if you simplify this fraction, this is just 5 pi over 4 radians. So the same thing. Okay, what about converting from radians? So from radians to degrees. Like, what if I have, say, pi over 4, actually let's just do pi over 4, whatever's. Pi over 4 radians is x degrees. How do I do this? Now, the conversion factor for this is just, you can flip the conversion factor for degrees to radians. So pi over 4 radians times 180 degrees over pi radians. The pi radians cancel out, and we're left with 180 degrees over 4, which is just 45 degrees. So that's just the answer. But then another way to think of this is pi over 4, right? So think of this as having a radius 1 circle. So the circle has radius 1, and how much degrees does it take for me to conquer pi over 4, the length of pi over 4, and the circumference? So the entire circumference is, 2 pi. And pi is going to be half of the circumference. So if this angle is that, so 180 degrees is pi length of the circumference. And if we halve that again, we have 90 degrees, or pi over 2 of the circumference. If we have that again, we have pi over 4, or 45 degrees of the circumference, which is what we want. So the answer is just 45. So this is just pi over 4 of the circumference. So yeah, and another problem. Okay, let's try another problem, and this video will end. So let's say we wanted to try pi over 3 radians equals x degrees. Now just use the conversion factor and we'll have the answer, right? So essentially pi over 3 radians times 180 degrees over pi radians, so the units cancel out, and also the pi's. We're left with 60 degrees, which is just our answer. You can think about it in this way again. You can draw a unit circle. Or another way to think about it is, how do I get, so I know that pi radians is 180 degrees. How do I get from pi to pi over 3? Just divide both sides by 3, like really simple. It's really simple algebra stuff. So this is just 60 degrees if you divide both sides by 3. So that's just the answer also. So in summary, basically, radians and degrees are both ways to measure angles. And essentially radians is different from degrees because degrees, you split the circle up into 360 pieces. Radians, you look at the circumference that the angle has covered. Like, you can imagine this angle corresponds to pi over 4 length of the circumference, and notice in radians, you assume that the radius of your circle you're drawing is 1. Like, for example, 360 degrees is 2 pi radians, because the formula for circumference is 2 pi r, and you just assume your radius is 1. We're going to talk about this radius 1 circle next lesson. It's called the unit circle. So like a circle with radius 1 is called a unit circle, and we'll talk about that next time.